Triumph Device Club meeting. My name is Daniel McDonald. Our speaker tonight is Daniel McDonald. Be giving a talk on ROS, Robotic Operating System. We're looking forward to the talk. Before we get into that, do we have any specific announcements or things that is happening next month or so, interested in robotics or speakers in this area? I know next Monday night has to be Triumph Ed. And those that are not attending that, that's a really good meeting. It meets in the next building over, EB2. Just go to triumphed.org, I think it is, website, for information on
in this building. It should be the next room.
Okay, all right. First, second Monday. We're always first Monday of the month. What's the second Monday of the month? Try in bed. And if you're looking for group of people interested in basically embedded for Arduino, used to be the Arduino group. Now it's expanded to Raspberry Pi and any other type of embedded platform. Really neat set of presentations. Really enjoyed attending that. That's definitely on the calendar for next week. Next month, blank on names. I'm sorry.
Charlie West.
Charlie West, that's right. And don't take person. I'm really bad on names. That's one of my negatives. Let's give you a talk. You want to give a brief description of the meeting next month?
Yeah. There's actually a research group and a actual set of the Department of Transportation group that's working on trying to come up with applications for autonomous quadcopters, trying to figure out what they can be used for and advise legislators as far as what they're supposed to be preparing for, basically, to make it legal. So we're doing a project for them trying to use quadcopters for bridge inspection. We'll be talking about some of the stuff we've been working with there.
And for those that made the meeting in the past, we have third out of 4 meetings in a row on quadcopters. We had one first on the legal implications of flying quadcopters in North Carolina. It was a very interesting talk. We had Dr. Conrad last month talk about the research project he's working on using quadcopters, former quadcopters, and going through down buildings to get through and navigating through that very rough environment. And then tonight's ROS, and next month is another one on the quadcopters. I read through the paragraph Charlie sent that's showing how to use quadcopters for bridge, looking at bridges and structures hard to get to the areas, and see and analyze that. It's a very interesting talk. Those are our December meetings. We're also working, hopefully, our meeting for January. Hopefully, we have. We're still up in the air with that one, and there'll be more information on that one later if that comes through. I'll leave it off until we finally get confirmation. I think the meeting in January also lined up. Yes.
Humanoid robot project.
Yes.
For those that don't know, we have a team that's working on building a humanoid robot. We meet the 4th Thursday of every month, but November that falls on Thanksgiving, so we actually pushed it out a week, so it'll be on December 5th, I believe.
It'll actually be a few days after the meeting, actually. Be Monday, so it'll be another reminder on that day. But definitely, if you're interested at all in the topics presented tonight of ROS, the topics of vision, sound, mechanical engineering, of building a walking robot, do something like see Lee or Grayson tonight and get you involved in that. Also, you can get volunteers to work on that project.
On Wednesday at the McKimmon Center is PCB Carolina 2014. If you're interested in doing your own fabrication of PCBs, assembly, vendors from the area and from the country, we'll have stuff set up. And they're way out of my league. I say, I want one. And they say, well, when you want 1,000, come back and see us. But it's interesting to see the state of the art and some pretty knickknacks and such.
The manufacturing exhibit is going to be.
Ulrich?
Yeah.
You've heard of that one?
It's here in Raleigh, and it's going to be in.
Days,
it's a couple of days from now.
So So laboratory robotic sensors is LRIG.
Well, no, not that
Oh,
one.
not that
It's,
one.
this is the fabrication people.
Okay.
The ones that all of the people that want to make things for you.
Okay, cool.
I'll try to test it.
I'm ready to go on that one. Find that one. The last thing, how many people actually are IEEE members? How many we have? We have 1, 2, 3, 4, 5, 6, 7. Cool. How many of those are senior? Seniors. Nice. Very good. That's two seniors. Those involved with the IEEE, basic seniors are those that have been involved with 10 years or more with the similar area of interest, and if you submit your name for that, and you get a review board actually looks at it and analyzes and improves that. So it's really good to reach that level.
And Rodney just became a senior.
I'll skip that off, so thank you. But yeah, I got my couple days ago. But that's thanks to his wife pushing him through to apply finally. After about 6 months, you get something to apply. But yeah, the reason I mentioned that is I was trying to have, recently a good idea, you know, a little dots put on our name tag. You can say the name tag is either a single language IEEE members, which were IEEE, which was a senior, kind of give it some sort of notifications and who they are. So you can be anyone, IEEE or not. So it's not a part of the IEEE. It's nice to keep back the fact that they actually are IEEE members, so we can move forward with that. That's all I have for now. Again, I'll read Anderson, everything that's
Is there a sign-up list on that?
I'm going to send it to you in a few minutes. Definitely on paper, but I'll pass this out in a few minutes. Do I have anything for Professor? I think one of the papers. Thank you, Claudia. All right, that's just paper. I'll pass it around. So, James did a nice bio of him. I'm redeveloping tonight, so I'm not very good at all the full details, but Steve is MA in Mathematics, University of Kentucky, and a BA in Applied Mathematics and Physics from Ashburn University. 30 years of software development experience, including 18 years of professional software engineer, software development manager, technical lead, built a variety of software systems from the ground up, including molecular modeling, visualization systems, 3D molecular database systems, data analysis and reporting systems, and supply chain and clinical trial management systems. He goes building and programming robots as a hobby. He's also in charge of the AI team. He's been on here for the humanoid robot project, as I mentioned earlier. They were really good talk at the last humanoid meeting on the AI he did. Actually, the great book he recommended called On Intelligence. I think his author's name is. And I'm probably reading that book now. It's a really, really good book. So if you're on the hook for a few months from now, I'll give you a little break, back to back. Once you get a talk on what you get in the humanoid robot project in the near future, true as well. It's a really neat way of thinking through for doing AI. Any more? Floor is yours.
All right, thanks. Thanks, everybody. So, hi. So, Rodney invited me to talk about ROS about 6 months ago or so, and I thought this is great. I'm learning ROS. I'd love to talk about what I'm learning, and I'll just tell you right now, I'm not an expert at ROS. If you came to get all your questions answered about ROS, I'll love to talk to you about your questions. I probably have them too. But I don't think I can answer many of them. But I do want to give an introduction to ROS. So if you are have wondered what the robot operating system is, you might have read about it or heard about it, and thought, I really got to learn more about what this is. Well, this might be the talk for you. This is a chance for me to just kind of give an introduction to this system, tell you kind of how it works, and give a little demo of how you kind of get hands-on with it. So let's get started, if I can figure out how to present my document. Okay, so this is the introduction to ROS, the Robot Operating System. All right, I got interested in ROS about a year ago. I joined this group around October of last year when there was a fantastic presentation on the Raspberry Pi. I was interested in that. I came and watched that, thought it was great, and I think I've come every time since, except for once that I was out of town. And when I was trying to get started in thinking about, well, how can I do robots myself? I always loved robots, and as a kid, I used to sit on my bed and try to wire up some motors and things, but I never really made anything that worked. But I wanted to try to make some robots. I just loved it. And so some people on the mailing list suggested, well, why don't you look at ROS? I had never heard of it. So I started looking into it, and for about the last year, I've been playing with it. And that's about as how much I know about it, is what you can get from playing with it in your spare time in the year. But what I've discovered is that this is a system that is just used by a lot of people and a lot of different robots. And so I wanted to start out with the ROS Robot Gallery and just to kind of highlight the variety of different and interesting robots that people are building with this operating system. And you know, everything from mimicking a hand to the Baxter robot, which is a very friendly, interactive manufacturing type robot, to research robots, the Stare robot from Stanford over at the right, the Adept robot for medical stuff. Lots of interesting robots. In fact, if you go to the ROS website and you look at their robots page, where they have all of these links to how to set up ROS on all these different robot platforms, it's just astounding the number of different robot platforms that all work with this interesting software package. The ones that are interesting to me, because I like Legos, and you'll see more of that soon, is the Lego NXT, the iRobot Roomba. I still have a plan to make to reincarnate my Roomba as a ROS machine that's carrying tools around my garage someday. All kinds of interesting robot platforms, from humanoid type robots to robotic arms. So what is this system, this robot operating system that allows us to work with so many different types of robots, so much different technology, and yet they're all using this same core? And so, when you want to know what anything is these days, you go to Wikipedia. And of course, if you're in school, can't use Wikipedia, which is crazy because it's got the best information on the earth. The robot operating system is a collection of software frameworks for robot software development, providing operating system-like functionality on a heterogeneous computer cluster. I thought I can't come up with a better definition than that, but I can try to explain what this means. And I think it's really shows some of the power of ROS when we start to look at what it means. So, collection of software frameworks. I'll have to move over here. ROS is cool because it has a lot of stuff in it. I like to think of it as the batteries included philosophy. A lot of frameworks say, okay, well, here's the pattern to follow, and you got to do all the work. Unfortunately, ROS takes another philosophy, which is, here's the pattern to follow, and here's a lot of examples of it working. Some of the key things, like there are client libraries, right? C++ and Python are the key languages that you would use for developing ROS capabilities and programming on your robot. But it also supports Java and C#. There are some Lisp client libraries if you're really into that kind of stuff. So a lot of flexibility for interfacing with the system. They've got built-in data types for actions, diagnostics, geometry, navigation, and sensors. So if you're passing some data around, you don't have to figure that out. ROS already has message formats defined for all that. It's got drivers for things like joysticks, cameras, laser rangefinders, and so on. It's got interfaces with 3D processing, the point cloud library. I don't know a lot about point cloud library. I've heard about it in the last few weeks. I'm really interested to see more about that, because there's some really cool stuff you can do with that in terms of taking point clouds from whatever kind of depth sensor you've got and creating surfaces, cleaning it up, building models, 3D models from that information. Really neat stuff. OpenCV image processing, coordinate transforms, right? You can define all the joints in your robot, and ROS will keep track of that and give you the power of saying, okay, if this joint is in a particular local coordinate system, particular orientation, what does that mean about its position relative to something else in the robot? So that kind of calculation, which is really important, is built in. That's really powerful. It's got some very cool stacks of functionality, like the navigation stack, supporting simultaneous localization and mapping. I brought along my probabilistic robotics book. If you've ever seen this book, very interesting book on how to make a robot navigate robustly in an environment. The algorithms in this book are available in the ROS navigation stack. So some pretty cool stuff. 3D simulation with Gazebo, and you've got the ability to define your robot, a model like this that you can actually model the robot on the computer, simulate how it's going to behave, and then transfer that to the physical robot and see how it works as well. So the ability to have the same software structure in the computer model and then put that on the physical model is a really powerful capability of the system. So lots of software built into it. On the operating system functionality side, as we said, it's a software framework with operating system-like functionality on a heterogeneous computer cluster. These are the types of things that it does for operating system, at the operating system level. Hardware abstraction, right? You don't have to figure out how to talk to a camera. There's a camera driver, you just get an image stream from it. Saves you a lot of time. Message passing, we'll talk a lot more about that. Package management, I don't want to talk a lot about that, but just to say that it's got a mechanism for a pattern for how you would package up your functionality to share with someone else. Right? If you've written some libraries, some functionality for a piece of a robot and somebody else wants to use that, ROS has a way to do that, which is really cool. Visualizers, we'll look at two more. Device drivers, I know nothing about. The other thing that I think is really interesting about ROS is that it works on so many different platforms, and they all work together. So I just listed a bunch of icons here that represent the technologies that I'm using on my robot. Right? So I've got Arduino, I've got Lego Mindstorms, I've got Android, I'm running Ubuntu on my laptop, writing in Python and Java, and running a Raspberry Pi. And all of these platforms are running some form of ROS, and they're all talking together through the ROS messaging protocol. It's really powerful to have, multiple platforms that can all integrate that way. So, how does it work? Let's get into some of the details of it a little bit. So the main way that ROS works is this simple program ROS core is where you start, right? So on my computer, for my robot, I run ROS core on this computer here. And I'll go ahead and start up ROS core. So move this window over. Can't see it. Let me pull my presentation out of the way. All right. Move the window open. All right, so when you start up ROS, right, you say, okay, well, I want to make a robot that works with ROS. What are you going to do? You're going to run your ROS core. Okay, so I'm going to run my ROS core, and it should start up here and say, core's up and running. That's pretty simple, right? I've got my core up and running. I've got a URL right there. It's got the ROS master URI. It tells me what it is. And that guy's done. He's ready to go. So that's pretty easy. But you got to have the ROS core running. The next piece that you need to make your things work with ROS, and the ROS core, you basically forget about it, right? You ran it, you started it, it's running.
Daniel.
Yes.
One slide, I have a question for you.
Go ahead. What's your
One
question?
slide back, we had the ROS core.
Yeah, let me do that presentation mode. And then back up a slide. Yes.
ROS IP, ROS master, different IP addresses. How do you ever set it up?
These are just examples.
Okay.
Right. So let me talk about that. That's the next thing. So the next piece to get everything talking together is to set these environment variables. And this is an example of what would be set on another computer other than the core computer. Right? If I were setting this up on the ROS core, I could set my ROS IP to be the same as the IP address of my core computer. But for some other computer in my network, I want to tell it where the master is, and then tell ROS what my IP address is, so that it can tell other computers how to talk back to me. This is a little bit confusing in terms of the configuration. It took me a while to figure this out. That when I set ROS IP, it's because my computer is going to offer some services to another computer. When I offer those services, I'm going to say, here's the service I offer, and here's the IP address that you can contact if you want to get this service. Right? That's the ROS IP. The reason I'm setting that is because I'm no network magician. I don't know how to set up all that DNS stuff and get all the name resolution working right on my network, so it's really easy to do IP addresses. Everything just works. If you know how to do network stuff, you don't have to set this up. The computer knows its name. It tells the other people services available at this name, and everybody just uses that name to contact it. It's quite simple. You don't need this. The next thing you do to get ROS going is there's two commands that you can use, two approaches to start up things in ROS. You can use the ROS run, in which case you give it a package name and the node name that you want to run, or you could use ROS launch. And one thing we'll see is that in a ROS system, you can have lots of things running, right? Lots and lots of nodes. And so if you use ROS run for everything, you're opening up a new terminal window, ROS run this. New terminal window, ROS run that. 15 terminal windows later, you're still opening terminal windows and starting ROS runs. ROS launch is a way that you can put all that in a file, an XML file, and say, one command, launch all this stuff. So that's really handy. Yes, Carl?
You do know that on Unix systems of any kind, you can put an ampersand at the end of your command line and have it all run in the background, so you don't actually have to open up more than one window.
Yes. I do know that.
Oh, okay, because you were saying.
The nodes tend to produce output that sometimes is interesting to see. And so
you want to see that.
You know, if I'm doing the ROS run approach, it's because I'm looking at the low level. I want to watch what's going on, right? Once I get satisfied that it's all working, then I'll just create a launch file and let it run in the background. But yes, because it's running on primarily Unix operating systems, yeah, thanks. One thing to note is that everything in ROS is in a package, which is why you always have to specify two names on the ROS run command line. The first is the package name, the second is the node name. And it will look for the node name anywhere under the package. But you have to have the package name to tell it where to start. I'm not going to talk a lot about the whole package structure and the file system structure. That's a complicated and somewhat boring topic for me. But there is a lot of that package management that ROS has, that how the code's organized and how you can share packages, and you have multiple nodes inside packages. It's really quite sophisticated. So moving on, so what do you do once? So we've got ROS core running, we know how to connect to it, we know how to run some nodes, and how does it actually work? So the real interesting thing, what I think is really powerful about ROS is the way it uses messages. So messaging is asynchronous, topics are created dynamically. I work in an environment where we have to use something called WebSphere MQ. Have you ever encountered that before? Nightmare. And when I saw ROS, I mean, I've been doing 3 years of MQ development, and just the horrors of having to do all the setup just to get a simple message from here to there. And I started up ROS, and I'm like, you mean I can just run the program? I don't have to create the topic first? I can just publish a message to a name, and anybody listening will get it? And that's really cool. It's exactly how it works. Everything's dynamic. All the topics are multiple publishers, multiple subscribers. So if you want to get a message that somebody else is publishing, just subscribe to that topic. You'll get a copy of the message. Very nice. And that's really powerful, because not only does it allow you to connect any two pieces of your system together and have them talk, but you can monitor what's going on. Right? You can create log viewers that listen in on topics and show you the traffic. And you don't have to do anything extra to do that. You know, if you've ever had to debug network communications where you couldn't get in there and grab a copy of the message, it's really powerful that everything works in a way that you can access it. The message formats are really simple. I just grabbed this one standard geometry messages for a point. It's defined in a file that's literally a comment line and 3 lines that say I've got an X that's a float, and a Y that's a float, and a Z that's a float. So it's not hard syntax to figure out how to understand and define messages. Really nice. Nodes can subscribe to topics, publish to topics, so it's just a few lines of code to do both, and I'll get some examples of that. Some of the commands that ROS has that allow you to interact with the system. So it's a lot of command line interaction that you can do. If you want to interact with topics, you use the ROS topic command. You can list to see what active topics are in the system. You can echo, which will print whatever messages are coming through on that topic. You can get info on the topic to tell you who's publishing that topic. We'll look at a few examples of this. I can actually publish messages into a topic. So I've got the commands to interact directly with the system right at the command line. Very nice. If you want to know about the messages, there's a ROS message command where you can list all the messages the system knows about. You can show the details of an individual message. So you've got built-in introspection into what is the transfer format. Cool stuff. In addition to the messaging, we've got services. So you think, oh, asynchronous messaging, but I can't implement my request response pattern. I only have asynchronous stuff. That's why ROS provides services. I need to make a request to somebody and I want an answer right back, right? That's what services do. If you need to say, call this guy and tell him to do something right now, you just send him a message, but if I need a response, then I got to use a service. Again, there's a ROS service command where I can call services directly from the command line without having to write code to do that. We can list services that are published and so on. So very nice feature of the system. This is, when I say that it's kind of batteries included, this is, ROS gives you all of this stuff out of the box, right? You're not having to figure this out. A lot of stuff. So you want to configure a robot. Maybe you want to have a system, a set of nodes that needs to, you want to run on several robots, but there's little differences between them, right? This robot has a capability that that one doesn't, so you want to be able to configure that. Well, there's a parameter server. It's like a global database, globally accessible database of name value pairs. I can put something up there, there's a parameter, and any node in the system can read it back down. And again, very easy. ROS param set, give it the name and value, and that stores that value up there, and then any node can pull that down. So it's a nice way to configure your system. Again, provided functionality. And this is one that there are visualizers that come with ROS, which I thought this is really cool. You've got RViz, where you can build a model of your robot and see it in a 3D world. You can provide meshes for other objects in the world if you want to do that. But as the robot moves, it can publish the transforms of its joints, and RViz can render that, what the robot's doing in that coordinate frame. So this can work both with a virtual robot as well as mirroring a real robot that's out there. So kind of cool. RQT is a program that has lots of plugins for showing you different things going on in the system. So it's the program that I want to learn more about because it's got a lot of capabilities and I just haven't played with it enough. All right, so now with all that sort of introductory, everybody's got the same understanding. Some people have a lot more, but at least everybody's got the same understanding of what ROS does. I want to kind of demo a bit about how this works. So this is my demo platform, and not everything I've got on this diagram, this is my vision of how it was supposed to work, not everything actually works. So I never got the speaker working here. And I do have all of these motors and sensors attached, but they don't all turn, just because I ran out of time. But basically I've got a robot that consists of 2 PCs that are kind of off-board, right, processing. I've then got on board 2 Raspberry Pis, each attached to a camera, one of them attached to 2 servos to provide the pan-tilt functionality. I've then got an Android device on the robot providing some decoration. I've then got a Mindstorms EV3 that's providing the drive for the robot and some other motion and sensor capabilities. And then I've got an Arduino on the robot that's providing additional motion and sensor capabilities, and it's hardwired into one of the Raspberry Pis to demonstrate how, well, obviously the Arduino doesn't have the Wi-Fi capabilities that the other computers have, but it can, ROS has a serial line connection that you can use that connects, that allows the Arduino to use the network of another computer to receive and send messages. So, here's the demo of that robot that I built for this. We'll get this guy started up. All right, so this is ROS. My Lego robot. And let me start plugging him up. What's that?
I was looking for where the Android, the
Oh, where the
The
Android
phone
is?
was, so you said you can get the speaker going, oh, there.
Right, and so there's my Android device right there. We can go ahead and get that one started up. Let's see here. All right. Got a little program on here called ROS tie, which gives him a nice, everybody see there? Got a nice bow tie. But like I said, it's a decoration.
There you go.
Okay. Then I've got here hidden in an access panel behind here, I've got a Mindstorm EV3 that should start up. If I'll start that up here. Let me go ahead and get my battery on.
Falling out.
What's that?
Something's falling out of your.
Something's
access
falling out?
panel.
In the back.
This? Yeah, I'm taking it out because it seems that the battery, I brought an extra battery. I tried to plug it in yesterday to charge it, and of course, apparently hasn't charged, but that's to be expected. You want to help me here, Samuel, with my pieces flying off? There we go. Get that battery out, and this one's charged. All right, so we've got the Android device connecting in, and we'll show how that works. I've got my Mindstorms device under here. What's that? Okay, yeah, you work on getting that set up for me there.
Now you got to do the real work.
No, you need to fix it.
Had he built it, it would have worked properly from the start.
All right, so we got. Let's look at the Android. All right, so I've got a. Let me see how I can do this. Good. All right. All right, so I'm going to try to run RQT, one of the visualizers, right? And let's see if RQT will show me my nodes. I'll put this over on the screen in a second once I get it working. So here's an example of RQT. So I was expecting to see my Android node showing up. It's covering everything. All right. So here's RQT. I started up a joystick node because I'm going to want to control this robot from my joystick. And so RQT is nice because it gives me a diagram of what's in my environment so far. So as I start up more things, we should see this diagram grow to show the various connections of things being started. Now, it should show my bow tie node.
Can you use both launch and the other mode to
Press
start
run.
stuff, or do you have to individually start each thing in RQT?
RQT is just a visualizer. It's just showing what's going on.
What's actually going on, and you could have run a launch, and
I could have run a launch, and I will run some launches.
and then you see it come up.
And we'll see. We should refresh this and see more stuff come out. I wanted this up on the screen so that as I start things, you can see how it's building the system up.
Yeah.
And so what I want, Samuel, can you check to see if that phone is connected to the Wi-Fi? And then restart that program, because if it's connected to Wi-Fi, it should register the node automatically when it runs. All right. You got the EV3 started? Did you push the start button? Okay, there we go. Now let's boot it up. All right, so we're going to boot up the EV3. And we've got our Raspberry Pis. So inside the head of this robot, obviously it has to have brains. So I've got 2 Raspberry Pis in here. I'm going to end up breaking everything, but I wanted to show you that it has brains. Okay. Stuck in there. Crammed in. What's that?
Eye controllers.
That's right. It's the vision of the system. Okay. And they're hooked up to 2 cameras. The camera's on the front. Actually, I was supposed to take the spectacles off and then say that, when my daughter saw the quality of the vision, she thought he needed glasses. And so she built some glasses for the robot because he wasn't seeing so well. Anyway, that's his glasses. All right, so let's connect up to the Raspberry Pi. All right, let's see, is my Raspberry Pi online? Okay, I've got a Raspberry Pi that's online. Okay, now. All right, I'm going to go ahead and get the other Raspberry Pi up.
Your remote showing into them and running ROS run or ROS launch or something?
Exactly. Exactly. So I'm going to remote shell over there, and so I'll show you here what I'm doing. Okay. So again, if I wanted to run this robot for real, have it convenient to start everything up and not try to demo how everything comes online, then I would have it start up on boot time and do all that kind of nice stuff. But for these purposes, since I'm constantly changing it, having things start on boot time would just be distracting from my project. So I tend to start them up this way. But for real robot, you'd obviously configure everything to start at boot. But for demos, it helps to see what's going on. And so I'm in my Raspberry Pi on the left side of the robot right now, or at least the left camera. And I want to so I've got a Python node called PyPan node that I've written. And when this guy starts up, then that actually gives me access to the servos of the head. So now we can see that my PyPan node is started up on the right. It's listening to the Joy topic, and Joy node is publishing. So the 2 are connected. Right? And all I've done is just run the 2 things. It's ROS that's connected them, which is really what's neat about it. So now I've got a robot that can look around. Cool. All right, so joystick messages going through the network straight over there, controlling the robot.
So your Raspberries are actually controlling the motors up here, right?
That's right. Yep, I've got the 2 servo motors. There's one that's down on the inside, that's going this way, and one that's mounted over here on the left. And the challenge, of course, was getting servo motors and Legos to work together because they're not the right sizes. So there's some Legos that are kind of bent under there. But yeah, the Raspberry Pi is powering both of they're micro servos. They don't draw a lot of power, and it drives them directly. And I'm running both Raspberry Pis off of a cell phone battery pack. And it can power them both just fine. All right, so the next thing I want to get started is, did the EV3 start up? I think I heard it beep. Yeah, it started up. Okay, so I'm going to go and show you that. So the EV3, the Lego EV3, right? It's a new thing that Lego produced, and it's quite a lot more powerful than their old microcontroller they had called the NXT. It's running a Linux operating system, and that means that you can run Oracle embedded Java on it, right? So because there's a ROS Java implementation, I grabbed all the jar files for this Java client for ROS and dumped them onto the EV3 along with the Oracle JVM. And then I can write Java programs that run on this Lego microcontroller that listen to Java, listen to ROS topics. And so doing that, I'm going to connect here to my EV3, bring up my EV3 control panel. Check what IP address this guy's got. 2008. 004. Okay. Why we check? So I haven't optimized all of the network configuration. Obviously, it's better if things come up with the same IP address, so you're not trying to find it. So I've got the program here. This is my EV3 control center. Right? I can search for my EV3. I find it on the network, connect to it, and once I'm connected, then I can remote control it. It's kind of cool. There we go. All right, so got a little. This is what actually is showing on the little screen there, but I get it back on my computer, which is nice. So I can navigate the menu system. Go pick my ROS program and run it. All right, that actually takes a little bit to start up, so we'll come back to that in a few minutes. All right, so the next thing, back to the Raspberry Pis. We've got this nice little head motion going on. You know, that's kind of cool. The robot can look up and around. Cattail, big loop. But let's get it to actually see something. So, starting with the left eye. All right, there we go. All right. So let's try. Okay, so I'm going to start up a node called RaspiCam. Now this is where we talked about the idea of drivers, right? So I wanted the Raspberry Pi camera to work with ROS. So I went and looked for where's a driver, a ROS driver for the Raspberry Pi camera. And there's a guy out there who's written a really nice one called RaspiCam, and it publishes all the right information that a ROS camera driver is supposed to publish. And it runs on the Raspberry Pi. And I can tell it what size images I want, what frame rate I want, what quality I want, what's the compression ratio. So if I want to speed it up, I could do that. And it comes up, and it's ready to go. Now I want to see that. Well, let's first of all check our RQT to see if RaspiCam is now there. It's not connected to anything, so it's node all on its own. It's kind of cool. Let me go and run something that will talk to it. All right. So we're going to run. That should work. Okay. So I ran this command, ROS run. So remember package and then node name. So image views the package, image views the node name. I'm taking my image from /camera/image. Hopefully I've got one of those. Let's check that. ROS topic, this. Yeah, I've got a camera image compressed. Okay, so that's good. Going back, so you see, because I know it's compressed, I said image transport is compressed. So it's, the Raspberry Pi is compressing the image before it sends it across the network. Now this opened up an image view window here, but there's no image. Don't worry. That's because my camera driver doesn't start generating images automatically. I have to tell it to start capturing images. So let's do that. And this is where the ROS service comes in. So I can call it. I can say camera start capture. Of course, I've got it spelled capture correctly. And we see, voila, we've got images. Of course, maybe.
That's not bad. That's a great image. I like it quite a bit.
Turn that up a little bit.
I don't like that part.
Zooming in. Which version
That's
of
right,
this?
zoom in on it,
Great question. So, this is another thing that I found really nice about ROS, at least my experience so far, is I'm running ROS Hydro on my laptop, but the Raspberry Pis are running ROS Groovy. And on this laptop, I'm running ROS Indigo, although I've had more trouble with that than I have with the others. So I tried to get a lot of things running on ROS Indigo, and I had a little trouble.
I haven't migrated yet. I'm still on Hydro.
Hydro seems to be pretty stable. I haven't had many problems with it.
Yeah.
But the instructions for setting it up on the Raspberry Pi were all written for Groovy, and I just followed them. I didn't want to try to take any chances because I just don't have time.
What's the difference between these different versions?
Indigo is the latest. Hydro is the previous version. They've restructured various.
It's like Linux
things.
kernel.
Oh, so they're
It's like
just-
Linux kernel.
Right, they're like, okay.
It's like, so GHI, Groovy, Hydro, Indigo. They just follow the letters of the alphabet and make up some word, usually vaguely related to turtles. I don't know. It's the ROS culture. I don't quite understand it yet. So, that's, having it installed and running a few nodes, we now get images on the screen. Let's go back to our QT and we refresh this, and we'll see what our robot looks like now. Okay, so now I've got my RaspiCam node, which was unconnected before, and now we've got this camera image compressed topic, which is feeding image view. And the image view node has given itself some unique name because I could have lots of different image view nodes. If I have many different image streams I'm looking at. So that's kind of cool. All right, let's move on through.
So if you want to start doing something with the image, then you could create your image processor node and have it just simply subscribe to this stream, right?
That's right.
So you start looking, using one of the packages to say, look for blobs.
And there's a ROS, I think called Bridge CD is what it's called,
Yeah.
which has takes the ROS image format and converts it to an OpenCV image format, and then you can just directly use the OpenCV library on that image. Now, in my case, because the Raspberry Pi is not a real powerful compute engine, right? So I probably want to have one reader from the Raspberry Pi cam node that's pulling that image. If I create another image viewer or another per node reading off the same topic, it's going to make another network connection to that same computer. And you're going to double the network traffic. So what I usually do is I have the Raspberry Pi camera node feed into a decompressor. There's a republish node, which will just read the compressed image and publish it uncompressed, because eventually I want it uncompressed anyway. And then I can run that locally. So I'm just transferring it from compressed image to a raw image, and then I can have as many readers on the raw image as I want. But they're all locally. They're not going through the network. So it's all just in-memory stuff on my laptop.
So if you built another process subscribing here, it actually doubles the bandwidth going on?
It might. I don't know. That's it.
Okay.
See, you're challenging my assertion.
Yeah, all right.
That's a
That's
good
fine.
challenge. I don't know. I suspected that it did, but it's possible that it's smart enough under the covers to I'm sending that frame so everybody gets a copy of it, but somewhere the copy's got to be made.
So where's ROS core at this point?
So ROS, from what I can tell, ROS core only gets involved in making the connection, right? It's the registry. It's a lookup. So you say, okay, once I go to ROS core, I get the IP address of the guy I need to talk to get my service, but then ROS core is out of the way. It's not a conduit of information. I get my information directly from the source.
Okay.
Which is why I suspect that if I have multiple image nodes, they're both going directly to that source. But you can do the republish thing, which allows you to move that processing to another computer for better throughput.
FYI, you probably already know this already, but for the sake of demonstration, it's obviously neat to do another node for image view. I think they have it now where you have your list of plugins under RQT, you can spawn in here an image view.
Inside of RQT?
Inside of here, as many as you want, actually. That's new with Hydro, as far as I can tell.
Yeah, I just haven't played with RQT enough. I remember going through the tutorials a year ago and I forgot about it.
Yeah,
And then,
they didn't even mention that in any of them, as far as I know. I just noticed it, so
yeah.
poking around up there.
But there's graph viewers where you can view like the signals over time. You can actually send messages directly to stuff from RQT. It's got a lot of plugins to give you a GUI onto the system. That's another talk in itself. All right, so let's quickly move on to what I really want to show, which is the stereo vision. So let's stop this guy. Where are we here? I've lost track of which. Out of the way.
One with the,
Yep, this one down below. All right, so to demonstrate the launch file, so I'm going to kill this node. All right, no more images coming through. Instead, we're going to do a ROS launch of the stereo left. So I've got a launch file that is set up for launching for running the Raspberry Pi, the Raspicam node we just saw, but it's configured it so that the data goes to the right topics for the stereo vision. So that's another cool thing that you can do with ROS, is because it's dynamically configured, you can have a node that default writes to /camera/image, that's my topic, but I can wrap it in a launch file that says, no, send it to /stereo/left, because that's actually the image stream that I want this to go to. So you can reconfigure that without having to recode or recompile things. So I'm going to launch my left eye image there, and now over my other guy, I'm going to do the same thing. Demo stereo right. So I've got another window on my other Raspberry Pi where we're launching this guy. And of course, I put it in a launch file for other eye because I want left and right. So that started up. These guys are out of the way. They're not interesting anymore. Refresh our notes to see what we've done. Okay, so now we've got a stereo left and a stereo right. Okay? Now on my PC, to actually do stereo image processing, I've got to start up a number of different nodes. And so I've got a launch file that's going to start up the node that's reading the left eye, the node that's reading the right eye. I've got a stereo image procedure that's combining the two, and I've got a stereo viewer that's showing the results of all of that.
Daniel, what is it about Joey there, the other client,
Ah, yes. Hold on.
I'm glad you're there.
The other program that I started several minutes back is finally picked up. So now I've got a robot that I can drive around on the table.
Yeah. There you go.
So that's what it is. Thanks for asking.
Very good.
So, I just love the fact that I've got one controller, it's generating one stream of events. They're going to completely different computers, completely different computer architectures, but they're all the same robot, so I can control the vision and everything all with that. That was interesting. Oh, I've got some arm motion there.
A little twitch, yeah.
A little twitch there, the cross nerves. That's cool. So I
he built
think
that
that
part, not you.
I am
So he built that part.
this,
Evo is doing the arm.
the ED3 is also picking up the signal from this joystick, the same signal that the Raspberry Pi is interpreting, and it's running one of its motors off of that same signal. It's a bug in my program. It's kind of cool. Yeah, little twitch there. All right, so we've got our stereo cameras going. So let me start up my stereo processing. So I'm going to do ROS launch, and what did I call this guy? Stereo pipeline. All right. This is going to start up a bunch of stuff. Let's refresh our screen here. All right.
Oh, wow.
So, in order to get stereo vision, we've now got, so this is our joystick that's controlling the motion, right? We've got our two cameras feeding in, right? We've got a left and a right compressor. They're handling, they're decompressing the image to a raw image that's going into our stereo image proc, which is producing a rectified image, right? So I've calibrated the cameras so that they give a rectified image. That's feeding into a stereo disparity, which is producing a stereo view showing the depth perception from the stereo camera. The camera info is showing that this camera node is actually publishing two topics. One has the images, and the other has information about the calibration of the camera, so that you can then interpret the image based on calibration information you've prepared ahead of time. So, if I now start, I need to do my ROS service call to start my capture. ROS service call, stereo left, start capture. My left camera is going to start capturing. Now I've got to start my right camera. And again, these could all be automated, but I wanted to walk you through step by step. Okay, let's see if I've got some images. Should get the images through on these.
Does RQT have a mode where the arrows give us differences based on how much traffic is on or something like that?
I don't know. Like I said, I haven't looked into RQT enough. It's something I learned about it when I first studied ROS a year ago. When I just first got into the tutorials, I completely forgot it existed. And then today, when I was kind of finalizing things, I was like, what's this RQT? I started out like, wow, that's really cool. I got to use that. But I just don't know all of its features yet. I mean, Ryan, do you know more about it?
I don't know. They continue to improve it. At one point, I remember they had it coded up in a different graphics framework. Then they migrated everything to Qt, and then they have this whole plugin architecture. I've not ever seen the arrows, like any modes where the arrows would change with. But if you spawn an image view in there as a plugin, you can select the topic and kind of switch around more easily than with the image views.
If you spawn it within RQT.
Yeah,
Yeah.
plugins are pretty nice.
Okay, that's cool. I'm just looking right now to see why I'm not getting images through.
If you start that last block in your process,
Let's start the last block in the process.
Stereo
So
view.
I just did the start capture, and the cameras have been renamed now because of my startup. So it's now camera left, start capture, which I called, and camera right, and this one happens to be camera 2, never mind that. So I started the capture on both of them, and I was looking to see what I did with my Raspberry Pi windows, and did I close it accidentally? I thought I minimized them. Let me try again. Alright, sorry about that.
The ones on screen were minimized.
You like to minimize them.
That's what I thought too.
I may have killed them from some other
Killed them
screen
some other way.
that we weren't
But
watching.
I don't see them here anymore. There's just that, not that one.
Refresh the screen there, so it's what it's showing.
Go back over the topic maybe. And you should be able to see.
Yeah, well, I seem to have killed those windows, which I apologize for that. Let me get them open again real quick, and we'll get it running.
If you refresh the draft, wouldn't those go away if you file for it?
Good point.
No, no?
Good point.
And we can always ping them also.
This, no, it's still running, right? The cam node is running on the fly. Okay, alright.
They have an integrated process monitor plugin, they had it also. It'll show all just the ROS related processes and number CPU and so forth that they're using.
Alright.
Under introspection.
Inspection, process monitor. Alright, that'll give us a visual of what's going on. The loads. Trying to recycle. Okay, so I've got, yeah, it's not showing my, rest of the notes. Well, there they are, right there. Let me see, if I refresh this, are they still in play? Cursor goes there. I noticed this process monitor thing seems to have sucked up my Oh, come on. Alright, so let's see, what do we got? I need to figure that out, but I don't want to waste all of your time doing that. Did you check the Android?
Yes.
Is it connected to the? Connected, but we're not seeing its node come up either. Oh well. Alright, let's get this fixed. So.
Connected to the local network. These guys are started again. Started. Look up Windows. And move this away, nothing coming through.
What happens when you do a ROS topic echo of your image topics? And you'll see a ton of gobbledygook, but
Right.
if they're publishing those. I'm just wondering if it's maybe the image views they're acting on.
Slash.
Should the image views be what? Be put up after the,
They're not on the graph, right? The images, they're looking at a different topic.
So
It's
I have
rename.
the stereo view here at the end. That's my one viewer, and it puts up 3 windows. I've shown 2 of them here. I'm hiding the 3rd one until it's worked.
Okay.
I'm wondering if those windows
Yeah.
have to be generated after the cameras are working.
Image views aren't up there, it's true.
The image views aren't.
There are 3 arrows coming out of your bubble at the end,
Right.
but maybe that's wrong.
I think they've lost the window.
The inline, the plugin for image view works pretty well.
My 3 windows, but I should have like a ROS 4 window somewhere. That's my ROS 4. All right. See, that's my joystick, my Eclipse window. Well, that's from some other testing I was doing. Yeah, it does happen. So, all right, we'll launch this all over again. There's our window.
There's 3 windows.
All right.
Let's just reinstall Windows.
All right. We gotta do that.
This Windows is like Windows.
So this isn't really an operating system. All these things are running under Linux and under.
It's only an operating system in quotation marks in the sense that it provides hardware abstraction, it provides communication protocols. It's, if you set up all the different computers on your robot to use this capability, it gives you a lot of that underpinning. You don't have to solve those problems yourself. You know, how do I get information from here to there? Publish it. And ROS takes care of the transport. But you're right, it's not really an operating system in the sense that it doesn't run on the hardware itself. There's an underlying it's a software framework, but trying to provide an abstraction above the hardware. And let me check my notes to see if I'm missing something. Yeah. Let's try it. So the other thing I wanted to show was the camera calibration, because that's kind of cool to see how that works. And again, it's one of those built-in things. But if I don't have the images showing up, then it's kind of hard to show.
Seriously, the image views kind of irk me. I've used them in the past.
It's been looking at me so long that it just gave up in its eyes.
Yeah, it's eyes are tight. The image view. So you're saying in RQT, let's try that.
Yeah. It's a little more.
Okay, plugins.
Should be under visualization.
Visualization, image view.
And there should be a topic select up at the top there somewhere. Drop down.
Alright.
This is why I wanted to give it process.
Is it getting any images?
Yes.
We have a right image.
Can spawn.
No, not
right
right
image.
image. Sure.
And I can spawn another image viewer. So this guy's got to be left. Right? Left image color, that's what I was looking at. This is right image color. Okay, good.
Blu-ray in this one.
Yeah,
This-
so I
this-
actually have, when I went to buy my second Raspberry Pi camera, they were out of stock on the regular one, so I bought the Pi Noir camera, the no IR filter version. And so the left image has the filter removed, and so it's more sensitive to infrared light. Which in this room happens to give it a better appearance. In other lighting environments, it looks washed out. But I'm interested in doing some experiments to see if it can, recognize a bright LED, infrared LED in an image that gives you some, if you do some image recognition techniques on that, have it respond. I've seen an electronic whiteboard created with that idea.
That's interesting.
You're looking for the
You see the
disparity.
stereoscopic.
It's also good for
See the
intrusion
stereo.
detection systems.
Intrusion detection?
Yeah, if somebody wants to intrude in your house, you can have the camera on when the lights are off.
So,
You can see a little distance on the one on the left.
Can I get to, there a disparity anywhere in there? I don't see it in the list, but I'm looking from the side here. Yeah, that seems to be, we don't seem to be getting that through the stereo image prod. But it produces a very nice disparity map that shows you in colors the depth. I really apologize that I couldn't show that. I really wanted just to see that.
Refresh the other graph.
Good point. Now we got more stuff in there. I wonder, can I move these around? Move this over here. Down below. Let's go.
Just tabs, down.
Get it going this side? There we go. Oops. Sorry, it's hard to control the mouse when I'm looking back over my shoulder here.
There we go.
All right. Okay, this is worse. All right, zoom this up a little bit. So we've got, now, I've got a camera calibrator that's attempting to start, but it's not getting the camera info it requires. And that may be what's going on with my stereo. Something may not be coming through.
Something else.
We've got, then, where's our image viewers? Are they showing up? I'm not seeing the image viewers show up.
It's interesting when you see how the left data is implemented through the calibrator. Where is it?
Right, we've got the 2D compressors here that are then feeding the camera calibrator. And the camera calibrator is nice. What you do with that is you print out these checkerboards of different sizes, and the size is actually measured from the number of crosses in the center of the squares, not the actual squares. And so this one is like a 7x6, and this is like an 8x6. And what you really want to do is have them be different sized squares. So I should have printed this one at a smaller size because they're almost identical, and so it doesn't really help me. But if they're different sizes, then it can recognize, oh, you're showing me the 7x6 pattern, and I know the squares on that one are, 2 inches, whereas this one is, 7¾ of an inch for this pattern. And then when you're showing it to the cameras at different depths and at different skews, right, and to the left of the image, to the right of the image, top and bottom, that it's tracking that, and it's calibrating the camera to know, it assumes this is a regular flat screen, and then it does all the math to figure out how the dynamics of your camera interpret that flat image. And that's how you do the camera calibration. So, and that's all built in. It's very nice. It's fun to do because
Does
it
it
shows
keep the data around for that? So you haven't changed the robot, you don't have to redo that every time?
And then when you're done with the camera calibration, which it's just not coming up right now,
Yeah.
it tells you, you can save it. and then it actually calls a set camera info call, service call on your camera node that stores that information with the camera. And that way then if you use that camera for anything else, anybody who wants it can go and get the info and have those mathematical transforms, the matrices that define the curvature of your camera lens, how it affects the rectified so that you can generate a rectified image and be able to see, straight lines are straight in the image as opposed to warping because of the lens effect.
There's, I bought an interesting camera at Walmart that they were getting rid of that is a 360 degree, well, it basically shows an image that's flat. If you put it on this table, it's everything above the table.
Right.
And it has a viewer that you can put on your computer that'll walk it around
Yes.
and correct it.
I would love to have one of those. And that would be really cool to put on top of a robot and have it see all the way around itself. Yeah. That's good for people following you.
See all 4 IR beacons at the same time.
That's right. So anyway, I think I'll stop here. I apologize that I couldn't get the stereo view and the calibration working, but hopefully that gives you a sense of kind of how it is to work with ROS and some of the capabilities of it. And, it's really cool stuff. Any questions?
How long how many hours did it take you to get to this point?
I started building that thing out of Legos last Wednesday.
Well, I meant ROS.
Get ROS to this point. I first touched it at Christmas time of last year, and I'd say I've put in maybe 60 hours on it over the year. I'm just making a wild guess. It's free time. A few hours here, a few hours there over the months. Usually I've done something for some project, figuring out how to get it to run on the EV3. I mean, it took me probably 4 hours to figure out how to get it on an Android phone over the weekend, and I never got it to show up. But I had a little thing where I could send a message to the phone, and it would change the time that the robot's wearing.
Let's do it.
I can try it. Nothing else was working.
Now, is this the operating system that the people that left iRobot wrote?
No, this came out of Stanford, and then it was developed at Willow Garage.
But Willow Garage is the people that came out of
Okay, I don't know
iRobot.
that.
One of the founders of iRobot.
So maybe the PR2 robot.
Right.
Familiar with that? That's a big one that was used to develop this.
That was one of the founders of iRobot.
Okay. Yeah.
From Stanford too, I guess. I thought the PR1 was developed from Stanford.
I think, yeah.
They called this thing Switchyard, I think, or something like that before they renamed it Bob.
Anyway, that group has disowned the PR2.
Why?
I guess it didn't get enough out there to justify.
Okay.
But there's another group that was servicing the PR2 that's continuing to support the PR2.
Yeah, I don't have my bow tie topic published, so can't change the time.
What can you say about what runs on the Arduino? It must be a sketch
So-
that interprets serial
Yes.
something from
Yes,
the
great
pi.
point. So that was was supposed to be part of my demo. So I've got an Arduino back here. It's wrapped in an NX shield, which is allowing me to plug in the Lego motors and sensors into the Arduino. It's just an adapter for it. And then I've got a USB cable connecting the Arduino up to one of my Raspberry Pis, so that the Raspberry Pi runs a ROS serial node, and that basically is an adapter for the ROS network, and it talks to the libraries that run on the Arduino. So for the Arduino perspective, you install a ROS serial Arduino library. Do a ROS make command, and it creates some stuff that you put in your libraries directory under your Arduino sketchbook folder. And then when you're in the sketch the Arduino Sketch application, you can import that ROS lib header file. And it gives you a bunch of APIs for defining your node, registering your subscriptions to topics, publishing things. It's got the standard messages, formats are all there in that, defined in those header files. And so you write your C++ code just like you would anywhere else. But when you're publishing or subscribing, it's going through the serial connection to the whatever computer's on the other end that's running this ROS serial node, which is then transcribing all that out to the network. So it really makes it almost a first-class citizen of the network, which is kind of amazing that you could get access to all of this. So if you've got sensor readings and things you want to publish, you can read them off your Arduino and just publish those messages as fast as you can. It's nice. I didn't succeed in getting it working. I would have demonstrated something if I could have got it working. There's some incompatibility with my version of ROS between the two. I've got it working between the Arduino and a PC, where I could send it commands and it would move a motor. So it definitely works. And I love the Arduino because it just has so many things it can connect to.
So is there a reason why you decided not to put a wireless on it?
On the Arduino,
Yeah.
I don't have one.
Oh,
And
that's good enough.
I mean, this is my stack. This is my tech stack that I play with at home.
Yeah.
So
Gotcha.
got all my pieces.
Also, the cost of the wireless Arduino is so much, you buy a Raspberry Pi for the same price as the wireless card, and you require nothing more than a network card. And that's the bad part about the Arduino and their wireless cards.
Yeah.
They're not cheap, unfortunately.
Yeah.
Are you powering the Arduino off the Raspberry Pi's USB, or does it have a separate power supply through the barrel jack?
I didn't plug it in, but I've got a separate power supply here that I can plug together. I've got a Lego battery pack hiding inside here. I took a old Lego wire and clipped it and stuck it into the power input for the Arduino. So to actually run the motors, I need this extra battery power. But it is starting up. It is powered up with the light on just from the Raspberry Pi.
For the disparity image, what is inside that node there? Is that a ROS construct, or is that something you wrote using OpenCV's disparity?
I didn't write any of this stereo image processing.
Oh, okay.
It doesn't work, obviously, on my setup. It worked at home. But I didn't write any of this, which is really amazing. And if you get the stereo image out, it shows you another image view here with like a colored pattern where red is close and blue is far. And then you can then get a point cloud out of that, right? So, and all of that's built in as well. That's my next step, is to get the point cloud and then use that to build a map and do navigation. But,
And are you using two PyCams for that?
yes,
Okay.
the two Raspberry Pi cameras. That's right. That's the images we're seeing are coming from, let me take his glasses off.
Does the
I've got these little holders that are protecting the circuit boards, otherwise they're exposed. But these are the two cameras.
does the disparity map actually turn out well?
It does. It's not great. I mean, it's definitely noticeable that you can see, if somebody's walking up, you can see the sort of the outline of their body, and you can see the color changing as they get closer. You can see the stuff in the background. It seems to recognize, sharp edges will create a clear disparity image. A blank wall, it can't tell anything. There's no detail in it. But I have a wall at home in one room that's got a wallpaper with a pattern on it. And that gave a very nice look because it could see the details in the pattern and match them up in the two images and get that disparity. I haven't tried a bunch of stuff. Like, I haven't tried different, distances between the cameras. I just built this and tried to see what it would do. Rodney's got a similar setup back there where his cameras are a little farther apart. So I'm very interested to see what he gets out
Mine
of it.
actually based upon the distance between my two eyes. That's why I set the distance apart and measured here, and you use for that to see. One thing I thought was very interesting experiments I've done recently is walking along, just closing one eye and and look and see what the eyes really can see in stereo. And I actually been very surprised at how little our eyes really see in stereo. Down at 15 feet, we don't see stereo, we see mono. And our eyes create depth by knowing this has to be in front of that, inferring depth from other things it already knows. But just close and look at two differences. It's very short distances actually see stereo. Unless you have a background that's way, way, way off in the distance, then you get further away. But it's really the delta between the foreground and the background. If you like a room like this, more than 15 feet out, you don't see any difference with our eyes. And ours are higher resolution as on the Raspberry Pi cameras.
Now, another factor with that is I calibrated my camera with this paper, right? So if you look online, they have these like big poster boards with big squares on them, and they get meters back from the robots. If with this one, I can only get from like this close up before it fills up the frame and it starts losing the edges, right? And I can get about this far back before the squares get so small it doesn't recognize them anymore. There's not enough pixels per square for it to say I can see the intersection. So probably I would get better results if I had both a smaller one where I could get up real close and it could get that close calibration, and a bigger one where I can get farther away, and just give it more data to work with, so it has a better model of the camera. Things I haven't tried yet. Anything else? Yeah.
Could you try using the projector to project the pattern structured light on a flat wall? Would that gain you anything, or you start mixing in the distortion from the projector?
I hadn't thought of that.
You have to have a known size, right?
It's important that for the calibration, the assumptions are these are square and they're on a flat plane.
You need edges.
And they're of known size.
You don't have,
And they're of known size. Right.
yeah, if you don't have edges, it's not going to tell. I mean, if you're in a whiteout, you have no depth perception.
Right.
Same thing as looking at a wall that's just white.
Right.
There's nothing to make a distinction between either eye. So you
It's
need
actually,
an edge.
it's
That's
very
why the
interesting.
edges work so well.
It's very interesting when you've got the disparity map. If you take this image and show it, it can get confused, right? Just like if you're looking at a tile pattern, sometimes the tiles sort of your eyes can cross a little bit. Well, the same thing happens with this, and it'll come up with this colored pattern where it's like oscillating between different colors as it's trying to match up the lines when there's so much repetition to it. So it'll get them off. It'll get them wrong. It'll match them to this one first, and it'll be really far away, and then it'll match it to the other one. Now it's really close. And it's really neat.
I think showing that that's a good idea. If you projected some light onto an area, you're actually creating a pattern that didn't exist before on a white wall.
Right.
And it'll be interesting to see what would happen in that case.
That's how depth cameras work.
Yep.
Right. They actually had that on the TR2 back before they put a Kinect on top of it. They had a textured light projector. You could actually, I don't know if you could actually see it, but it was definitely visible in the videos they took of it.
And Kinect also has ROS on it as well. If you've been looking at Kinect, that's an incredible device. As you mentioned, there is a camera in there and also a structured light source that sends it out. And even the libraries go into the Kinect. Not only give you back the image and the depth, but also gives you back, it knows what the human body looks like, gives you back the angle of each of the joints in the body coming back. You don't look at a blob here, so it tells you the elbow is this angle, this angle, all that comes back from the camera. It's pretty incredible, the libraries and hardware goes with that.
Yeah.
Unfortunately, this project, you can't use a Kinect because we don't have it in our eyes, but it'd be a fun project to play with. I've got one with my TV thinking, coming off the game system any day now, to play with my laptop to play with, but I haven't taken it down yet.
Yeah, it'd be fun to play with one of those. Because it gives you a rich data stream, including, arms and leg joint positions and things.
Pretty cool.
Pretty cool. All right, anything else? Yeah.
If you want to debug the flow between these, is there like a way of right-clicking on, say, left decompressor? And I didn't know what the message is. If it's kind of text-based that flow.
It is. So let me show an example of that. If I can find my cursor. So here's just a simple example of of what the messages look like. So I've got ROS topic echo joy. So if I want to see what's going on, maybe there's probably a way in RQT to do it that's really neat and slick and gooey like. This is what I know. So I can echo the joystick stream. There's a joy topic out there. And now when I press a button, it happens. Right. I actually see what the joystick message looks like. And I pressed and I released. That's 2 messages that came through. And you can see, okay, it was button at position 0 that got pressed and released. Everything else was the same. So with each message, the entire state of my joystick is being transmitted.
Yeah, you have topics with subscribers and publishers, but then you also have a call response with ROS service.
That's right.
Is that call response as debuggable as topics? Or is that just like a private communication?
I don't know. That's a good question.
I don't know either.
I've not used the services a lot. I know their message formats are similar, but when you build a service, you create a service file where you define what's my request message look like, what's my response message look like. But in terms of debugging, I've not read anything that says here's how you intercept those messages and see what they look like.
See, the reason I ask is I wrote something similar to this for cash registers, and the
Okay.
whole point was instant debugging by just looking at message streams.
Right.
This command was sent, this response came back, and none of this binary debugging. Now, of course, the camera data is going to be some big
Right.
blob of semi-binary data.
Right, right.
Echo the disparity topic. I wonder if there's anything you can going through that.
I don't think we're getting, I think something's wrong with the stereo image prompt, and it's just not. It maybe isn't seeing the sync on the cameras for some reason. I've had a lot of problems because I don't have hardware synchronized images. So a good stereo camera is going to have hardware synchronized, so the images are exactly at the same time, right? And by default, the stereo image pipeline is expecting that. Since I don't have that, I have to provide this approximate flag that says, match up any images that are within, a tenth of a second of each other. And so that reduces the quality of the data stream, but it allows it to work with lower quality software, hardware, right? But I've had problems with it not matching up the images, and particularly with the calibration, I've had to run it with different values to try to figure out how much approximate it is. I think a lot of it has to do with the network environment, because I've got these, 2 Wi-Fi cards right beside each other, with these big antennas. I don't know what kind of problems there might be with that. Usually I get pretty good.
Run them at different frequencies.
Different channels.
Different channels.
Yeah, that's just, I'm not a, I'm a plug and play when it comes to that, so I don't know how to do that.
But then the receiver wouldn't be able to receive both at the same time.
I'm assuming that the Wi-Fi kind of does that automatically. My router for the 2 of them is right here. So it's not far away. Anyway.
You could run both of your Ethernet ports to a switch and only have one Wi-Fi.
As far as the radio itself, if you have your antennas at right angles to each other,
Yeah.
they will not interfere.
Then the interference is minimized.
Yeah, let's put it that way.
They'll interfere.
They'll interfere.
Not orthogonal.
You don't have to actually
They look
do horizontal,
orthogonal, they're
as
not
long
truly
as they're,
orthogonal.
they could be like this, right? And they're still at right angles of each other.
That means your receiver also is at right angles before guaranteed to one of those 2.
Right, right.
Yeah, it'll just have a weaker signal
Right,
strength.
you weaken the signal.
Looks
About what,
getting
I think it's about
decent
18
frame rates on those though, so.
Yeah, so
Yeah.
I've got it set for this demo. I had it set at 12 frames per second. So that's the 2 cameras coming through. It's decent. They're not perfectly synced. You can see some lag on one side or the other.
Well, point it at yourself and then wave at it.
Point it at myself and wave. So, and it handles the stereo as well, once you get that working. Anything else? Thanks for all the
Thank you.
questions.
You didn't have to get up
Thank you
and
very
say
much for the
them all.
presentation. One thing I didn't do at the beginning,
Wow.
I was missing,